Hello, welcome back to Math 152. We're going to finish up our Chapter 2 today with Section 2.4, and the title of this section is Graphs Can Be Misleading. So our objectives: understand how improper positioning of the vertical scale can be misleading, understand the area principle for constructing statistical graphs, and understand how three-dimensional graphs can be misleading. So what are we talking about when we're saying graphical misrepresentation? Well, statistical graphs, when properly used, are powerful forms of communications. They're visually, you can see a lot of data at one time. Unfortunately, when graphs are improperly used, they can misrepresent the data and lead people to draw incorrect conclusions. So in this section, we're going to discuss three of them: incorrect position of the vertical scale, incorrect sizing of graphical images, and misleading perspective for three-dimensional diagrams. So what do we say when we're talking about positioning the vertical axis? The baseline of a graph or plot is the value at which the horizontal axis intersects with the vertical axis. With graphs or plots that represent how much or how many of something, it may be misleading if the baseline is not zero. So these graphs are based on the same data but give different impressions. The graph on the right has a baseline of 47, which exaggerates the differences between the bars. So basically the whole scale is thrown off between here. Here's the tens, and now we're going 47, 48, 49. But we're starting here at 47, so it looks like there's a big difference between 2006, 2007. But if we give the full scale, here's the 2006 data, here's the 2007 data, and they're almost at, pretty close in terms of millions of passengers. If these were individuals, it may not, but these were millions of passengers, so it really exaggerates the percentage differences or the changes between here. Okay. So if you look over here, we didn't start at zero. These are millions of passengers, so it looks like they're really changing a lot, but in terms of millions, they're not changing that much. You can do this if you do a time series plot. Here's those. You remember the time series where we're doing our dates across the bottom, our time units, and then here's the value. This is the very same thing. It looks like we're just starting out here. You're going to ignore this just by looking very quickly at the chart. Somebody throws it up on a slide. Here's our data. Look how much we've changed. But if you really look at it in terms of where you should, to be honest, there's not that much change between here. There is, like 48 to 50, but in terms of millions, that's only 2 million. So the area principle, you've seen forever that images are used to represent amounts as well. Larger images correspond to greater amounts. So to use images properly in this way, we must follow a rule known as the area principle. So you may have seen this in geography a lot, where they represent, let's say each car was 10,000, so you may have 3 cars to represent 30,000. At the same time, it may be the size of the car, so a bigger car would represent more. So the area principle: when amounts are compared by constructing an image for each amount, the areas of the images must be proportional to the amounts. So for example, if one amount is twice as much as the other, its image should have twice as much area as the other image. So here's the problem if we're not aware of the area principle. Here's 2 different ways. The cost of jet fuel in 2003 was 83 cents per gallon, and in 2013 it had risen to $2.87. So note that the price in 2013 is about 3.5 times the price in 2003. We're starting at 0. There's this price, 3 times it. So we have jumped 3 times. Now in the bar graph, that's the area. So that bar is about 3.5 times. The width is the same. The height of this, if I add these, stack this up, that means 3.5 times. So the area is really increased by 3.5. In the plane image, the difference appears much larger. This little plane looks to be much larger than this 3.5 times. So what has happened is that they have basically did the height and the width increasing 3.5. So this went 3.5 this way, 3.5 vertically, and that overall area turns out to be about 12 times as great, 3.5 times 3.5. Here it just goes up. This basis things, this would have been, if we did messed up the area principle here, this would have been 1, 2, 3 times as big, and it would have been like a huge bar. So the airplane graph violates the area principle and gives a misleading impression, so just be aware of that. They did length 3.5, height 3.5, but when you're doing the area, it's always the length width times the width, and that made it much larger. Three-dimensional graphs is another visual representation that's used frequently. It's nice to have a three-dimensional bar graph in here. Like here would be the cost of jet fuel, different years. Unfortunately, the way to make this look three-dimensional is to really tilt the graphs, make sure you've got the full dimension here and here, and then make it look down kind of in this perspective. If you think about it, if I kept rotating this thing so that we're looking directly down on here, all we're doing is looking at the tops. So this scale, this vertical scale gets really distorted. So unfortunately, in order to make the tops of the bars visible, these graphs are often drawn as though the reader is looking down on them. This makes the bars look shorter than they really are. They get distorted, so it doesn't give a good representation of the difference between this and the 2013. So that kind of finishes up. This is a short section. We just talked a couple of different ways about how graphs can be misleading. Incorrect positioning of the vertical axis, incorrect sizing of graphical images by not following the area principle, and then how three-dimensional graphs can distort the perspective. Remember, we always need to start at the 0. Keep our graphical images by doing the area, not lengths and widths, and then three-dimensional graphs are always going to distort somewhat what we see. Okay. Hope you found this useful. See you next time. Have a good day.